स्टार्ट हो गई
हो गया सर। उनको मैं पानी का बॉटल रखने के लिए बोलूँगा।
क्या?
उनको पानी का बॉटल रखने के लिए कहूँगा और रखने के बाद इमेज खोल के शुरू कर सकते हैं।
हाँ, रखो रखो, अभी नहीं स्टार्ट हुआ।
ये चाहिए 7 बजे मिलेंगे।
ओके, yeah, let's get started. Okay, so science and technology, current affairs. Now, I think you both are from A7 batch. Huh? A7, C7. Okay. Both of these, I don't think we have started with science and tech. Okay. Now, see, some topics are very easy, so those you will be able to understand. In some, you will be able to make general sense of it, but deeper understanding you will gain when you do the classes. Now, this is first thing about. So basically, PIBs have now become important. PIB is what? Investigation Information Bureau. Okay, so basically government releases everything, whatever official communication it wants to do or whatever it has done, it tries to give it to the media using PIB. Now, there are many questions that were picked directly from PIB in this year's prelims. In earlier years also, it is picked directly from PIB. So now what happens when newspapers or some coaching institute picks it from PIB, they tend to miss one or two things here and there. And sometimes questions are based on that. That is why I have directly picked it from PIB only, whatever I found important. And then there are some other topics which were in news, in the newspapers and everywhere. Now, so this is Dr. Jitendra Singh announces ANRF portal for training in patent filing and research paper writing. Now, he is minister, he is the Union Minister of Science and Technology. Now, he has announced ANRF portal. Now, first we have to understand what is ANRF. Okay, so this is mainly a research funds. So first we'll understand that, then we'll come back to this one. Let's understand ANRF and RDI fund. Now, first thing, what is this? So this is Anusandhan. Anusandhan is research in Hindi is called Anusandhan. Okay, so research, National Research Foundation, like that it has been named. Anusandhan National Research Foundation, ANRF. This was established by an act, ANRF Act 2023. Now, because it has come from act, it has statutory status. Okay, that is why it was important. It was notified on 5th of Feb 2024. This is the date from which it became applicable. This was the date when it was passed. Bill became an act, and this is the time it becomes applicable. Now, it is India's apex. Apex means the topmost body. Apex statutory body. Why statutory? Because it has come from an act. Okay. Then for research and development, then what it does? So it funds academia through grants for early stage research and hosts rupees 1 lakh crore research development and innovation fund. Now Let's understand the two things. First, this statutory body you understood, it has actually replaced the Science and Engineering Research Board. It used to be there before. Now, the governance part of this, how it is, how the entire structure of governance is there for this ANRF is the most important thing. If they give a question, most probably it will have at least one of the statement based on this. This is the governance. Now, understand. So it works like this. At the top most, who is chairing this board? The board that is there is chaired by the Prime Minister himself. So he is the chairman. Then after that, the Science and Technology Minister and the Education Minister are the vice presidents. Okay, so Science and Technology, Education Ministers are vice presidents. Then other than that, there is also an Executive Council. Okay, which will look at the technical aspects and all that. That is chaired by Principal Scientific Advisor to the Prime Minister. So this person is the head of the Executive Council. Then the overall administrative mechanism, that who will be doing things on ground or managing things, that will be done by Department of Science and Technology. This comes under Ministry of Science and Technology. This is the last line that is written. Department of Science and Technology is the administrative ministry. So this is the governance structure. Now, of course, if the PM is chairing it, so you can understand that it is an important body. It has come by an act chaired by the Prime Minister himself. Then now let's see the core grants. Now, before that, you understand how things are divided in research. So basically, there are TRLs. Now, what is this? What is this? This is technology readiness level. That how ready is the technology to come in the market. Now, if it is at stage 1, that means it is right now only an idea. Then after an idea, they will come up with some kinds of experimentation and it will keep on going. The 6th TRL level is called demonstration. When they make the first lab based demonstration that it will work like this. Then after that, they will test it in different ways. They will test it with different materials. They will test how the market will behave. Eventually, this will become a market product, which is the technology readiness level 9. So this is 1, this is 9. In between, you have 6. So it goes like this. Now, the part that you see here, idea to demonstration. Now, this actually requires a lot of money and it has low return capability. Why low return capability? Why? Because this is fundamental research. You are doing the research at a very fundamental level. It will not make into a product immediately to give some money back to you. Now, don't you think that especially if I talk about TRL 1 to 4. So TRL 1 to 4 if you talk about, no private industry really wants to invest in it because it has to invest a lot of money for example, fundamental technologies like developing new kind of LLMs, large language model, cost a lot of money. You aren't even sure that you will be getting back this money. So this has to be taken care by the government, and for this the governments around the world usually give grants. Directly they are giving grants or money that you do research on this. Now here also first thing, so there are two components of this ANRF. One is core grants, where they are directly giving some money and asking you to do the initial levels of technology. So this is first, which is the core grant. So this provides grants in aid to universities, national labs, hospitals, Section 8 institutions, Department of Scientific and Industrial Research, CSIR. So all these research entities, it provides direct funds. Then supports early stage and high risk research with technology readiness level of 1 to 6. Understood? Then major program. So now the major program here is supports broad based schemes such as Anusandhan Research Grant, PMECRG Research Grant. So all these are research grant, and they also do some mission projects, like some mission project on electric vehicles. All that is done within this. This is the first way that ANRF works. That is giving money directly for the initial research levels. Then you come to RDI fund. This is the second way. Now, so rupees 1 lakh crore research development and innovation fund. This was approved by Union Cabinet in July 2025. Now understand how this one works. So here it is not about just giving the grants, giving the money, expecting no return. That is not there, because now we are talking about, so this the second one starts from TRL 4 plus and goes till 9. So here you will be getting a market product eventually, so you can get money out of it, correct? So this private sector would also like to invest in. So here government is trying to do the thing that they will be taking the returns also, not just giving funds away. So here the process works like this. So the government, the money that you are seeing there, for example 1 lakh crore that you saw, so the government will transfer this to ANRF. This is the research foundation, correct? Now from ANRF will give it to second level fund managers. For example, NBFCs, you know, non-banking financial companies, okay, companies that provide loans to other companies, all those. So it will give it to them. Now these companies will now give money to the startups or MSMEs or whatever. Now if startups turns out to be well, it starts earning money, then for that this will gain money, and the money from here will be recovered by ANRF, and then from ANRF it can go to government, or ANRF can use it again for developing more and more things in science. So you're understanding, here you are trying to get output out of it also. So this is 1 lakh crore RDI scheme. Now let's see this. So funding model provides patient capital for technology readiness level 4 and above. Then support is provided through loans, debt, equity and hybrid instruments with flexible repayment terms. Then fund management. So see, government provides funds to NRF as 50-year zero interest loan. They are not trying to make money out of it from ANRF. For 50 years they are giving it at 0%, but it is a loan still. So they won't be taking interest, but they want the money back. You're understanding? This is 0% interest loan. Then ANRF acts as the custodian and appoints second level fund managers such as AIFs, development financial institutions and NBFCs, and eventually it gets to the startups. This is the chain. Then yeah, so eligibility. Now of course they won't be giving this out to any kind of random startup. Kuch naya app banaya, some new app that will deliver bottles to your home. Now for this government won't be funding, correct? So this is mainly about deep tech sectors. Deep tech, okay, that is artificial intelligence, quantum technologies, biotechnology, that will have impact in the entire ecosystem. Those research government is trying to fund, okay? So and the last is expected impact. So government is saying what? Because in the second one RDI we are targeting TRL level 4 and above. So let's say we invest 100 rupees, then the private sector also, because it can gain money out of it, would like to invest, let's say 500 rupees, 400 rupees. Eventually the total amount of money that goes to the startup will be like 600 rupees. So this is written here, aims to leverage private investment by 3 to 10 times. Whatever government invest, for example, government is investing 1 lakh crore. So it expects the private sector also to put in 3 lakh crore, 5 lakh crore, like that. It is an expectation, because this, from this you can make money out of. Then potentially mobilizing 4 to 5 lakh crore and adding about 0.25% to the GDP. Okay. Last thing is IP policy. So here what government has realized is, see, researchers don't have any kind of incentive to do the research and everything. So earlier what used to happen, if it was done in a government body, let's say some government institution, government used to fund it, so they used to send tenders that, sir, we want this money to do some research. Then the government gives them that, they do the research, then whatever product comes out, that government takes. But there is no incentive, correct, for a researcher. So here what they are saying that we'll be following BioDoe inspired model where researchers retain ownership of intellectual property while promoting wider technology diffusion through licensing. So those researchers will own it, correct, or that institution will own that, and by licensing it will give it to others. Licensing, if they give via licensing, if they give it to others, they will be charging some money, so they will also be gained. So this is earlier government was doing everything. Now incentive for researchers was low. Now this system has come. Then now this is the difference between table. We have already understood everything, just have to see that everything is flowing or not. Okay, first ANRF core grant, support basic and applied research, support early technology. Then here scale industry led deep tech innovation, support consumerization and expansion, TRL level 4 and above. Then instrument is non-returnable grants. You don't have to give anything, we are giving you grants. Here loan, debt, equity, hybrid finance, because we want the money back. TRL focus, technology readiness 1 to 6, here 4 and above. Then who are the beneficiaries here? Universities, research labs, hospitals, non-profit institutions who do the fundamental research. Here who is the beneficiary? The ones who will make money in the market, startups, MSMEs, private companies. Okay, then last is funding nature. Funding nature, in this case it is government grant simply. Here it is return seeking patient capital. Why it is saying patient capital? Because the government is not in a hurry. For example, the private investors that are, they are usually in a lot of hurry that I have invested so much, now in 3 years I want return this, that. So that is why it is patient capital. Then now let's see this news also, what he said. Okay, so recently what they have done, they have announced ANRF portal for training in patent filing and research paper writing. Correct? As you understood, if you want to have a product, all that, for that you have to file patent. So for that they have made a portal. That's it. Then providing structured support in scientific writing, publication process, intellectual property protection, patent related procedure, all that. Now what they are saying that eventually if through this portal they want to convert this, that is scientific work, whatever was done should be converted into publications in research papers, and then it should become IP asset or intellectual property assets. This is the aim for that portal. Portal is not that important, the scheme of ANRF, how it comes from that act, all that is more important. Then also on the sidelines, because the minister was there, so he discussed what are the different things that we are going on aiming for. So basically the minister further reviewed preparations for ESTIC 2026. What is this? This is Emerging Science, Technology and Innovation Conclave conducted by Department of Science and Technology every year. So what, this is a simple conclave. What happens in conclave? So all the Indian institutions, private entities, whatever, if they have made some product, they want to showcase it. Now showcase it to other kinds, other companies, other people, also some foreign investors that are coming. So that is done in ESIC 2026. So he reviewed that how is the progress going on. Then, yeah, so the meeting concluded with a collective commitment that we should be coordinating more, all these research institutions should be in direct contact, all that, institutional capacity, enhance the visibility and societal impact of scientific research and innovation. That also is suggested that every research that you do should be shared in a like normal citizen can understand in that form, so that science and technology innovation is promoted in India.
This is a training for that.
No, this is not training for that. See, it started with that we are launching a portal. Now, when they do such meetings, no, so when the minister is sitting, everyone important in this whole ecosystem, except for the prime minister, was sitting there. So they will review many things. PIB is for informing what the government is doing. So that is why this also is covered. That what they are doing, what they are going to do in the next 3-4 months, that is there. Okay. Next, this is done. Then, next is 75 lakh households targeted for rooftop solar installations by December 2026. Now, there is this scheme called Pradhan Mantri Surya Ghar Muft Bijli Yojana. Okay, once question has also been asked on this by UPSC in I think 2025 or 2024. Okay, 25 I guess. So now PM Surya Ghar Muft Bijli Yojana, what is this? Understand this. So basically government is giving subsidized solar panels to different households. Now in your house also what you can do is you can take the subsidized solar panels and install it above your house. Now from that solar panel you can make electricity and use it. But the problem is, the earlier problem is whatever the electricity that you were generating, now it is very difficult for you to transfer it to the grid so that you can get money out of it or anything, correct? So it used to be very difficult. Then the government ensured that they ask all the discoms are distribution companies that distribute electricity all around the city. So they asked the discoms that what you should be ensuring is that anybody who has rooftop solar installed, they should be able to transfer solar energy or electricity directly to the grid and then take from the grid as well, so that this becomes a simple chain. That was the plan in PM Surya Ghar Muft Bijli Yojana. The plan is to get to 1 crore households. Okay, so right now they have recently crossed 40 lakh beneficiary within 2 years, and this minister was hopeful that by the end of 2026 we will be crossing 75 lakh households. The eventual target is 1 crore households. These targets will keep on changing. Okay, so you try to remember this 1 crore households and how much he'll be getting to. So one of the numbers, some idea you should have. Either if you just remember 1 crore household, that also is enough, because these achievements will change by the time you give exam. Then, now see, there are 2-3 terms that you need to understand, otherwise it's very simple. So this is utility linked aggregation, is what I explained you, that if there are 1000 houses, they won't have 1000 systems. So they will try to have one aggregated project that will be managed by DISCOM, so that all of those houses are managed by the same DISCOM and they can easily send whatever electricity they have produced to the grid. That's it. Then, will particularly benefit families consuming 1 kilowatt to 3 kilowatt of electricity, because if they are consuming small enough, then that solar panel itself will be enough for them. The scheme is witnessing strong public participation. So government is right now not able to provide to all those people who have already filed for applications. Okay, then they also talked about 2 more things which are important for solar energy. One is battery energy storage system. So they are saying that after this we'll be focusing on BESS, Why these are important? Because solar is not available in the night time, so you need very good quality batteries and all that. So that is one thing, and other is Model Solar Village Initiative. So what is this Model Solar Village Initiative? Like there is Model Village Initiative. So here what they will do, they will try to develop, let's say in one state, let's say in Karnataka, they will develop one village. In that one village, they will try to do all different use cases of solar energy. For example, they will use solar energy to heat water, they will use solar energy to cook food, they will use solar energy to produce electricity, they will use solar energy for submersible pumps. For everything they will try to use solar energy, and that will become a model solar village for others to copy. Okay. Then he talked about that as of May 2026, 12 gigawatt capacity has been added through these solar rooftops. Again, this will change. This is him. Then next is next generation nanomedicine can silence key cancer drivers. Okay, now this is very technical. Okay, essentially it uses 2-3 chapters together, that is nanotechnology, that is biotechnology and health. These 3 chapters are correlated here. Now I'll just give you a general idea what is happening here. See, next generation nanomedicine can silence cancer drivers. Now first understand this. You know what is this? This looks like something we know as DNA. Correct. Now see this. This looks like an RNA, something like RNA. Correct. Now there is something known as small interfering RNA. We'll read all about them. Small interfering RNA does what? Let's say this part of your DNA, okay, this part is not good or is causing cancer in you. So you don't want this part to be expressed in you, correct? So what you can do, you can design certain small interfering RNAs, and these small interfering RNAs will do what? Okay, so these small interfering RNAs will do what? They will go and get attached here. Now because of this part of your DNA won't get expressed. Okay, this is called small interfering RNA. It is interfering with the issue part, and in this way what it is actually doing, it is not editing, cutting out, nothing. It is doing something known as gene silencing. It is silencing this part of the gene. This is called small interfering RNA. Now, so what they have done here, now you also know about nanotechnology. What is nanotechnology? Nano means very small, correct? 10 to the power minus 9 meter. So nano means something very small. So using some very small carriers, that is of the size of nano, correct? They have made it as a platform. So basically using this nano size particles, they have developed a platform. Platform is something that can carry anything. So they have made a platform. Now through these platforms you can very easily carry and precisely deliver small interfering RNA, because you have to deliver it very precisely only at that location, correct? Now if you just leave it, small interfering RNA, it won't reach there and get attached only there. So you need some platform. That platform has been made by nanotechnology, which makes it very accurate so that it sticks at the correct point. This is what they have developed. So next generation nanomedicine can silence key cancer drivers. So scientists from Pune have reported a gene silencing strategy that can drive effective tumor inhibition in breast cancer, highlighting its potential as next generation precision nanomedicine. Okay, now just 2-3 things we need to understand. Now, who developed it? This we must remember. This is Agarkar Research Institute, Pune. This is an autonomous institution under Department of Science and Technology. They have developed this. Then, what is that platform made up of? This we need to remember, that is biodegradable. So the platform is biodegradable. Mesoporous silica nanoparticles. Okay, silica, you understand? Silica gel you might have heard. Okay, silicon oxides is what you know as the simple soil that you see, that is SiO2. Okay, so based on that, biodegradable mesoporous silica nanoparticles is what has been used as a platform. Now if you read it, you will get some idea. Okay, the system is built on biodegradable mesoporous silica nanoparticles, well known for their high loading capacity and tunable surface chemistry. So they are acting as a platform then, which enable efficient delivery of small interfering RNA molecules. Understood? Now, of course, this has started with this. If we are able to deliver small interfering RNAs very precisely, then this can be used in some other diseases, some other use cases also.
Is this more like a preventive or a proactive one?
No, this is not preventive. This is treatment. Yes. So basically, if some tumors have been developed, then you are inhibiting or silencing those so that they don't spread. Okay, so that you stop their turning more cancer cells, all those. Okay. Now this is too much detailed. That is not needed to us. Then this is cork glucon plasma. Okay, again a very.
Is it a treatment for all the cancer kind of?
No. So they have developed a platform and shown and demonstrated it that through this platform we are able to do some inhibitions, particularly in breast cancer. Okay, right now it is at demonstration state. As you can see, if now you understand technology readiness level, correct? So where are we right now? At the research institute, correct? So we are still at the demonstration and the phase earlier than that. It has not become a market product. Okay, so it will take time. Then now cork gluon plasma. Now this is about particle physics. This is something that I take as the last lecture. Okay, because it is difficult to understand. Now see, Big Bang, you know, Big Bang, everything started with at a point and then this whole universe was created in a few seconds, not even a few seconds, in some parts of the second. Now what was happening? You know about proton, neutron, all these. So now proton and neutron are actually not fundamental particles. There is something that makes proton and neutrons also. Okay, like electrons is a fundamental particle, but proton and neutron are actually not indivisible. So they have something. Actually, if you take just proton, so proton is actually made up of 2 up quark and 1 down quark. These are varieties of quark. Okay, quark is some elementary particle. Now, when these combine, they make a proton. Similarly, neutron is made by just the opposite. Now see this. So what has happened? See, at some point in the Big Bang, it was too hot for proton or neutrons to exist, at that time these quark and gluons used to be in free state. So quarks are those particles, 2 up 1 down, like that. Now of course this cannot become proton, it must be bonded by something, correct? Now that bonding thing is made from some kind of glue that we call as gluon. So gluon actually joins them and this whole thing becomes a proton, correct? But in the earlier time, at some point in Big Bang, it was so hot that this process was not done completely. So then what will happen? These quarks used to float around independently and these gluons also were present independently. They were not able to make proton or neutrons. Now, so what is quark gluon plasma? So it is that state in which protons and neutrons are not being able to meet. And that is why you have a combination of certain quarks and gluons that are floating around. This is QGP. Then an extremely hot and dense state of matter consisting of quarks and gluons. Then existing during the first few millionth of a second after the Big Bang, before protons and neutrons formed. Then produced experimentally through ultra high energy nuclear collisions. So this they have made in certain kinds of lab. We'll understand what kind of lab is this. This is Large Hadron Collider, where they have developed this. Okay, where they have demonstrated that something like this can be made. Okay, now among the hottest substances ever created, reaching trillions of degrees Celsius. Then now see this. So what has happened is this. So now scientists at Large Hadron Collider LHC discovered the smallest known droplet of QGP. So during an experiment, now how Large Hadron Collider looks like, it is like this. It is like 27-kilometer circular ring. Now because of some magnetic properties, basically they attach magnets here and the particles that are moving are usually charged. So because of magnets, they start moving very quickly in this round and round, so much so that they almost reach the speed of light, that is 3 into 10 to the power 8 meter per second. Then they take two particles in opposite direction and then they try to collide them. If they collide them, then because it is at such high speeds, then the particles that were actually making it, they would interact and they would give rise to something different. Usually if you take one proton, they won't break because they are very strongly glued by that gluons, correct? But if you collide them hard enough, then they come to their fundamental states, and that is done in Large Hadron Collider. Then, so earlier they used to be based on some heavy nuclei. Now they have recently done it in the oxygen nuclei based collisions. So that is the new thing that they have done. Then, despite containing only a few thousand particles, it behaves as a near perfect fluid, showing collective flow and very low viscosity. Now, why it is called a different state, this QGP? See, it is at some trillion degrees Celsius. Now, anything at a trillion degrees Celsius should be what? Should become ideally like gaseous, correct? It should not remain like or behave like a fluid, but here it behaves like a fluid. Small particles, of course it is not visible anything, but the properties it shows is like a fluid. That is why it is considered a different state of matter. Like you have solid, liquid, gas, plasma, Bose-Einstein condensate. This is another thing. Okay. Now, so how they know? For example, fluid you understand? This is fluid, correct? So now, fluid is something that has continuous transfer of energy. Now, of course, they can't look at it. So how they define that this is behaving like fluid? When the bulk motion is dominating over individual particles. For example, here, if you see how it is flowing, correct? So everything is continuous, correct? You can see a continuous flow. That is bulk motion is dominating over individual particles. While if I take some gas, now usually the air is not visible, but if I take a gas that is visible, let's say of blue color or something, you will see that particles are going in different directions, correct? So there particles dominate, but in a fluid, bulk motion dominates. So by that they are able to guess that this is like a fluid. that it is behaving. Helps identify the threshold at which matter transitions are happening. Then, now what is LHC? This I have explained you. World's largest and most powerful particle accelerator located at CERN, Switzerland. This is European Organization for Nuclear Research. Consists of 27-kilometer underground ring that accelerates particles close to the speed of light before collision. This is Large Hadron Collider. If you know about God particle or Higgs boson particle, okay, this was discovered in 2012. That was also done by this LHC only. Then, yeah, so India is not a like the founding member or anything like this, but we started contributing in LHC, that is Large Hadron Collider projects. India joined the project in 1996. DAE, Department of Atomic Energy, and CERN you already understood, European Agency for Nuclear Research. So then we have contributed in different ways. We have contributed hardware, software, scientific expertise, okay, critical components, detectors, basic some things we have given them in this project. So Large Hadron Collider is basically, you understood the structure is same, but what they are essentially doing, they take some two different particles and then at very high speed they collide them. From that they understand what is the fundamental properties of that particle, like protons, like some atom of some element, okay, some kind of different kinds of neutrons, everything they will keep on colliding. Then they get to some result. When the result is good enough, they prove something, then it becomes a research paper, okay. Then last is this, nothing much, very easy. So this is what? This is DRDO and IAF conducted successful flight test of Rudram 2 air to surface missile. Air to surface, you understand? That is, let's say I am going on a aircraft, from air I am dropping it on the surface. Correct? Surface means on earth. This is air to surface. Correct? So it will look something like this. Like if this is an aircraft, it will drop the missiles like this on the ground. Okay, so Rudram 2 is this. DRDO and IAF, Indian Air Force, have conducted successful flight test of this. Now, what are these? What are some properties about Rudram 2? So, this is an anti-radiation missile. Anti-radiation means basically, see, if it is trying to target some kind of, let's say, some kind of fighter jet of, let's say, Pakistan or some other thing of Pakistan. Now, those fighter jets or anything will be releasing some radiation, some signal, correct? It may be in radio waves form that we cannot see, but it must be releasing some kind of radiations. Now, those it is able to observe that from there I am getting the radiation, and based on that it can change the direction and follow that radiation to hit the target. That is called anti-radiation capabilities. That is from where, for example, something is being released by the fighter jet, some radio signals. So from that radio signal it will understand, oh, that radio signal is coming from this, so I should change my direction here and go towards that. It will constantly be doing this and then hitting the fighter jet. So this is anti-radiation. The range is around 300 kilometers.
Is it like a bat, sir?
Is it like?
Movement like a bat.
Bat?
How a bat navigates?
No, bat is actually using sound waves. Yes, this can be anything. This can be heat waves also. This can be any kind of electromagnetic waves. Correct?
So it just avoids the place where the stimulus is coming from and then
Yeah, so it tries to move in the same direction. Now, bat use only sound waves. Okay, sound waves it sends and then receives it. It is very similar to that, but just more advanced, and it uses all kinds of electromagnetic radiations. Okay, that's the only difference. Then 300 kilometers solid propellant. So the propellant that we are using is solid, liquid, all these are propellants. Hypersonic. Hypersonic means it is going at a speed of greater than 5 Mach. Mach means number of times the speed of sound. So 1 Mach is speed of sound, 2 Mach is 2 times the speed of sound, 3 Mach is 3 times the speed of sound. Greater than 5 Mach means more than 5 times the speed of sound. What is speed of sound? So speed of sound in air or vacuum conditions is usually considered 340 meter per second. Now this is greater than 5 Mach means into 5 and something, so it will be like more than 1700 meter per second. That kind of speeds it is going at. Okay, so this has been again developed by DRDO, and this is how they have conducted the trial. The missiles after release were guided to a predefined target with a pinpoint accuracy, and they said that all the test objectives were met. Then indigenously developed by DRDO. That is it. That's the range. Range as in, for example, from here, how far can it target? Correct. So 300 kilometer far is what it can go. Short range. Okay.
Why is it anti-radiation?
Anti-radiation means basically if there is some radiation coming from any different source, it is able to recognize it and act anti or against it. That's why it is called anti-radiation capabilities. Okay. Okay. This is it for Science and Tech Current Affairs. Thank you.
So, are there any MCQs to solve? Thank you. Sir. You will.
MC